Hello students, hope you're all fine. In the last class, I gave you certain ray diagrams to be drawn and to be practiced to, and exercise 5B question answers also I asked you to mark in your book. Now, in today's class, I have shared already with you few images. So, in the back exercise of exercise 5B, there were two ray diagrams which I could feel are important, and I really want you people to check those answers. Okay, so those two ray diagrams are to be drawn in register, the ones which I am sharing you through the help of images. Okay, uh, one of the ray diagrams, it is, they are talking about the convex lens, and the other is about the concave lens. So both the ray diagrams are important, so must be done in the register. Okay, and further we are going to now today start the class with lens formula. Okay, this all we have already taken. So today I'm going to start the class with lens formula. Pay attention students. We all know there are two types of lens, concave lens and convex lens. Now the lens formula is 1 upon f equals to 1 by v minus 1 by u. Fine. Now here the derivation is given in your book, which is not a part of our syllabus, so I'm not taking that. Okay, you are not supposed to do that, it's not a part of our syllabus, so you have to straight away start with the formula itself. Okay, now what are these terms? See, we all know when there is a lens, there is some distance of the object from the lens, and from the lens basically we means the center of that is the optical center. Similarly, the distance of image is also there from the optical center. So we are using symbols for the same. Pay attention. If lens formula is 1 by f equals to 1 by v minus 1 by u, then here u stands for the distance of object. Pay attention student, it is the distance of object from the optical center. It is for both the lens, concave as well as convex lens. Okay. Next, the distance of image from the optical center is called the image, that distance, that is small v. We use the symbol small u, small v for the same. Okay, u is for the distance of object from optical center, that is O, and v is the distance of image from the optical center, O. Fine. Now we are going to move further, students. So here I am going to talk to you regarding f. What's f? It is the focal length. In definition also I have shared it with you in the previous class. Okay. So the distance of the principal focus from the optical center is called the focal length, that is OF1 or OF2, because they are the same. So the distance of principal focus from the optical center is called the focal length. Now since we know that the image formed by a concave lens and convex lens, the image formed by a concave lens and a convex lens are having different characteristics. Am I right, students? When I talk about convex lens, it converges the light rays after refraction. So what happens in that? Real image can be formed, at the same time virtual image is also formed, right? The image formed is having same size, diminished, magnified for the convex. But if I talk about the concave lens, the characteristics are the image formed is virtual, erect and diminished always. I repeat students, for concave lens, we all know that the image formed is always virtual, erect and diminished. So depending upon that, the value of u, v and f will have certain signs. Okay, for concave lens and convex lens, as the characteristics of image formed vary, so we will have the symbol form, the signs for u, v and f. Okay, now let's understand the term magnification. When I say it is a convex lens, what kind of image is it that we get from it? It is virtual, erect and magnified. That means bigger in size. So how will I write it symbolically? That m magnification is greater than 1 for magnified image. When am I saying that the magnification is equal to 1, students? What does it mean to us? It means that the image and the object size are the same. So here we are going to talk about this particular term called as magnification. Now, what is magnification? Yes, it is the term magnification means a comparison between the size of image formed by a lens with respect to the size of object. Earlier, we were talking about the distance of object, distance. Okay. Now we are talking about the size of the image formed by a lens with respect to the size of object. Okay. So whenever I take this formula, this ratio, this comparison of any two quantities is the ratio only. So whenever I take this ratio, what I get is the term magnification. So for a lens, I can conclude and I can say magnification M is the ratio of height of image to the height of object. Clear, students? Right? So I can write it in formula form. M is equal to height of image H dash upon height of object H. Clear? So this is the formula that you need to learn, because in the numericals which we are going to start, you will be questioned about the same. The magnification you'll have to find out, and then you have to write this. Then you have to tell what will be the size of the object, whether it will be magnified, it will be diminished, or it will be of same size. So using this formula, you can talk about it. At the same time, we will be given the value of the focal length, say, or the distance of and the distance of image from the optical center, or we will be asked to calculate u. So we are going to learn now the sign conventions. Why positive negative signs are needed? I'm again and again saying sign conventions because we know the characteristic of image formed by a concave lens and convex lens vary. Here we have seen in the previous class these ray diagrams also, right? What happens in these ray diagram? Yes, the image formed, see, for convex lens, when I talk about, these are all for convex lens, the image formed is different. It is formed at focus f2. It is formed between f2 and 2f2. Then it is formed at 2f2 of same size as that of object. That means these are all variations we can see. Okay, it is formed at infinity in this case, and here it is between O and beyond 2f1. So that is the magnified image we are getting. So these are the reasons why we are going to have different signs for f, u and v when I compare the two, that is concave lens and the convex lens. For concave lens, we all know that always the image formed is diminished, virtual and erect. This is for sure. So let's learn the sign convention, students. Okay. See, when I say the positive sign is there in magnification, it means positive sign means the image is virtual, while negative sign in that it means the image is real. Also, positive sign of magnification indicates that the image is erect, while negative sign indicates that the image is inverted. Student, these are the points you need to learn, because when I'll be taking the numericals, I'm going to straight away tell this is real image, this is inverted image. How will you get to know? Using these formulas only. So you have to run screen number 1, this formula, lens formula with the meaning of each. Next, the magnification formula with the meaning of the term. Okay. This height can also be taken as size of image, size of object. It remains the same. Okay. Next, the sign convention of magnification, how it concludes or how it tells us or how it indicates what it indicates regarding the virtual form image or the real image or the inverted or the erect image and all that. So this is what you'll be taking help from. This is what is going to help you. Must learn it. Let's move to the next. Now here in this part of the same, from chapter 5, last part, also we have power of lens. The power of lens, students, is measured in diopters. Okay. When I say you are using any kind of lens, say we have a problem of like we are not able to see the nearby objects, then in that case we say it is long sightedness. It's just the opposite word is used. Okay. When I say that it is the nearby objects can't be seen, the objects, far off objects can't be seen, so accordingly we are using the concave lens and the convex lens. Okay. So also the bifocal lens, you must have heard people using it, the one who are not able to see nearby also and far off objects also very clearly. So here we are going to understand this particular topic, power of lens P. Okay, which is measured in diopters. Okay, you must have seen the prescription also, that when you get your eye checkup done and like that they write plus minus values and then they put capital D. That is actually the diopter for the lens which you need. Okay, so focal length is F. We have just now discussed in the previous lens formula, which is measured in meters, and which gives us the power of lens P equals to 1 upon F. So I repeat it, power of lens is equal to, students, power of lens is equal to 1 upon focal length. Power of lens is equal to 1 upon focal length. Okay. So what is 1 diopter? Is the power of lens whose focal length is 1 meter. Pay attention, this particular part is very important, students. See, power of lens. Power of lens is reciprocal of focal length. So how can I define it? It's so easy. It is the reciprocal of focal length. What's the unit of power? It's diopter. This is not that power, work, energy, power. Okay. This is the power of a lens, specifically the word is there. So be very clear. It is going to have unit capital D symbolically and diopter like this. This is the word. So it is the reciprocal of focal length. Focal length is always in meter we take. If even if it is given in centimeter, the conversion in meter is must. Clear, students? So the SI unit of power is diopter. 1 diopter is the power of lens whose focal length is 1 meter. Okay. Now also there are two more important points I am sharing with you which are needed. Power of convex lens is positive and power of a concave lens is negative. I repeat, power of a convex lens is positive and power of a concave lens is negative. Fine, students. So this is what you need to learn before you start doing the numericals or taking the numericals part. Clear, everyone? Okay. Now also I have shared with you the image from the same. Okay, image from the same. When the object is in front of lens, the image formed is in front of lens. What is the sign convention that we take? We take it as negative. And when the object is the image formed is, object is always in front. When the image is behind, the image formed is behind the lens, it will be taken as positive. Okay, the distance of the image and the object needs to be taken using this sign convention. Okay, so I've shared with you already this particular part. Fine, students, you have to learn these sign conventions, then only it is going to help you, which I've already, as I said, I've shared it with you in the form of images. Okay, so for convex lens, when I say the object is, where is it placed always? For concave and convex, we know the object is always placed in front of lens. Object is always placed in front of lens. So when it is placed in front of lens, I've already told you this particular part I've shared in the screen in the form of image. It should be as it is there in your register. So whenever the image is in front of the lens, it will be taken as negative. So U will be negative for both. U is what, students? It is the distance of object from the optical center. So it will always be taken negative, because we know whether it is a convex lens or a concave lens, we always place the object in front of the lens. Clear this part? Let's take the next thing, that is the focal length. We know for convex lens the image formed is real. Okay, fine. So when it is real, convex lens focal length is positive. Okay, and no virtual focus is there. So for convex lens, F is always positive, and for concave lens, F is always negative. Clear, students? As far as focal length is concerned, for convex lens it is always positive F, and concave lens it is negative. Clear this part? Only thing now left is, because the magnification part I have discussed with you, the height of image and object I have discussed with you, only part left is V. Now very clear. When the image is in front of the lens, we will take it as, image is in front of the lens, we will take it as negative. And when the image formed is behind the lens, it will be taken positive. That means for concave lens, we know that image formed is always virtual, erect, diminished. So for concave lens, U, V, F. I repeat, for concave lens, U, V, F are always negative. Clear, students? Clear, students? Once again I am repeating. If the object is kept in front of the lens, the image is kept in front of the lens, we take the sign convention U and V negative. If the image formed is behind the lens, we take V as positive. So for concave lens, U and V both are negative, because the image and the object both are in front of lens. Okay, and focal length, As far as F sign is concerned, it will always be negative for concave lens. So learn this thing. For concave lens, U, V, F are negative. Convex lens, since real virtual both kind of images are formed, convex lens only for the last case. Okay, the ray diagram which I have shared with you today, right? So in that, what I have told you is magnifying, as a magnifying glass it is used, right? So in that particular part, is it clear, student? Magnifying glass, which, when is it used? When the object is placed between the optical center and f1. So then in that case the image formed is beyond to f2, right? So that is as a magnifying glass. In this particular we are using this convex lens. So here it is going to take the sign convention. Here it is going to take the sign convention, okay, as negative. Other than that, convex lens, always we will have the image formed is behind the lens, okay, so it will be positive. Learn all the rules that I have shared with you. These signs are very important, because when I'll take the numericals I won't repeat it. So this is your homework. All the images that I've shown, I've shared with you in the form of what, a screenshot. So that must be done by you all, and this much must be revised. All these formulas and concepts must be revised properly. Thank you, guys.